Okay, so there's no real roots. If there were real roots, they would cross to the x-axis. So if there aren't any real roots, what kind of roots are there? Imaginary, or what we call complex roots. Okay, an example of a complex root. When you guys do the quadratic formula and you get an answer like this. 2 plus 3i and minus 3i. Okay, that's a complex root. So if that's the root, and so basically you've got this root that exists kind of like in this imaginary plane. Okay, and that's why it's called imaginary. Okay. If you guys end up doing like calculus later on, you'll find out more about what all that means. Okay, so 2 plus 3i. So if that's the case, then how do I find the equation then? Because I can't just go like x minus 2, right? I have to account for that imaginary part too. So it's very similar, okay? It's just going to require you to deal with imaginary numbers, okay? So let's just start over here. And let's say that the roots that you have are this. Well, first of all, that's not just one root, that's 2. The first one is 2 plus 3i, and 2 what? 2 minus 3i. Okay, and so what I'm going to do is do like a side-by-side example here so you guys can kind of see how these are similar, but how they're different. So actually, let's go over here. Let's say that I've got 0, oh, sorry, let me start it over. Let's say I've got 2, 0, and 3, 0, negative 3, 0 as my, for one example. But for this example, we're going to do the 2 plus 3i and 2 minus 3i, okay, as our roots. Okay, so if I was to do this example, y equals, okay, we're not even going to worry about the stretch factor. Okay, let's not put in the a value. We'll just, do like a possible equation. So here would be x minus 2 and x plus 3, right? And then you would multiply that out. So maybe after I do the box, okay, actually let me do the box right here real quick. So remember, my number's on the outside. X squared minus 2x, 3x, negative 6, and then add all those up. X squared, 3 minus 2, x, and then minus 6, right? All right. So now with this one, I do the same thing. Okay, so here, I look at the first number, okay, and what I'm going to do is add, or I'm sorry, subtract it, because it's positive 2. All right, so what I'm going to do is 2x minus that whole thing, like this. Okay, and then I'm going to do it again. So x minus, again, the same thing. But now I have to simplify that. Now, if you guys notice, I got parentheses within parentheses. So here, with that negative, I'm going to first have to distribute that because I've got a negative outside of parentheses there. And so now that's x minus 2, and then plus 3i. And then again, x minus 2, and then plus, I'm sorry, that's not plus, that's minus, because that's negative times the plus there. My bad. Okay, then here, distribute to that, and I get plus here because negative times negative. Okay. Now I got to multiply that. Now, are any of these like terms? No. 3i, 2, or x. They're all different. So I got to multiply all of these together. Okay, so I have a 3 here and 3 here. So what kind of box do I need to make? 3 by 3? Yes, 3 by 3. Okay, so now I'm going to put these factors on this side. and these factors on this side. And we're going to multiply out each term. Okay, so the first one, we'll have x squared, then minus 2x, then minus 3xi, because we've got an x and an I together. Okay, then here it's going to be minus 2x plus 4 plus 6i. Okay, because negative 2 times negative 3i. I'm just multiplying all the way through here. Now, again, here's 3i times x, so 3xi, except this time it's positive. Okay, and then 3i times negative 2 is negative 6i. And then the last one, negative 3 times 3, well, that's negative 9. Now, I times I is I squared. Okay, now let me, off to the side here, I'm going to write a quick note. I squared, do you guys remember what that's equal to? Negative 1, yes. Okay, so that means that in there, it's going to be negative 9 times negative 1, which will be positive. So I'm going to just kind of pull this to the side. This ends up being that, right? Which is equal to positive 9. Okay, just so I can kind of save myself a step here. All right, now let's add it all up. Start with x squared. I'm going to look across the box, see any other x squareds? No, just that one. Okay, now I've got negative 2x and negative 2x again. So that will be negative 4x. So done with those. Then I'm going to go to this 3xi. Well, it has to have an x and an I. Well, that would be this one and this one. And it's 3xi and negative 3xi. So what happens to those? They cancel. Because it's 3 minus 3. Okay, so I don't have that one anymore. I'm going to save the 4 for the m because it's just a constant. There's no x or I next to it. Then I'll go to this one. 6i minus 6i. What is that? That also cancels. A lot of times when you do these problems, numbers are going to cancel out. Okay, when you're dealing with imaginary numbers. Okay, now I've got 4 and 9, and I'm going to write this out just so you guys can see it. Plus 4, and then plus 9. And remember, the 9 came from negative 9 times negative 1, because I squared equals negative 1. Okay, so then add that up. X squared minus 4x, and then add these two, gives me 13. And there's my equation. Now, yes, sir.
Doesn't I also just equal negative 1?
I itself, just I, is equal to the square root of negative 1. And so when you multiply square root of negative 1 times square root of negative 1, then it ends up equaling negative 1. Okay, that's why I squared is that. Now, let's take a look at what this equation looks on the graph and make sense of that, because we said that we started with complex roots to start with. So let's see what that means like on a graph. So that makes a little bit more sense as to why we're dealing with these complex roots. So I'm going to graph this, x squared minus 4x, and then plus 13. And notice that graph is not on the x-axis. Okay. Now let's say I change this to minus 13. Notice what happens. Now I've got x-intercepts crossing the x-axis. But as long as it's not touching the x-axis, that's what's causing it to have a complex root. Now if I make this negative, did anybody remember what happens when I put a negative in front of an equation? I'm about to put a negative there. What's going to happen to the graph? It's going to flip. What's their flip called? It's like when you look at yourself in the mirror, it's called a reflection. So it flipped. All right. Do you guys think that has real roots or complex roots? Complex, because it's not touching the x-axis. Okay. So that's kind of the key here, is it's not touching the x-axis. All right. So let's look at the homework assignment. So right here on this first problem, it says, Spud has a problem. He knows that the roots of a quadratic function are x equals 3 plus 4i. So there's the first root, 3 plus 4i. And then 3 minus 4i. So there's your roots. Okay, just like when we did this one over here, we started with 2 plus 3i and 2 minus 3i. Well, this one is saying that, scroll here, scroll. Okay, there we go. This one's saying here that those are the roots. Okay, 3 plus 4i, 3 minus 4i. But in order to get credit for the problem, he was supposed to have written down the original equation. Unfortunately, he lost his paper to the original equation on it. Luckily, his friends are full of advice. Well, so first friend says, just remember that we made factors from solutions. If you wanted 7 and 4 to be the answers, you use the opposites, x minus 7, x minus 4, just like we talked about. Use Alexia's idea to write the equation. So that she's talking about what we just did. Okay, I just basically took those factors and subtracted both of them. Okay, and then worked backwards. Okay, and then we had to use the box to kind of multiply everything out. Okay, Hugo says, no, you can do it. You can do it that way, but that's too complicated. I think you just start with 3 plus 4i, 3 plus and minus, or 3 plus 4i and work backwards. Okay, so here's what he means. All right, you can work backwards as well. All right, so let me give you an example of how to do that. How to do it with the box, but also to work backwards. So I'm going to take those same factors. Let me clear this out. So 2 plus and minus 3i. So what I'm going to do is just take the plus version, right? And I'm going to put it down here kind of at the bottom. 2 plus 3i. And we're going to say x equals 2 plus 3i. Okay. What I'm going to do is, I don't know if you guys remember the method of completing the square, but I'm going to work backwards with that. Okay. So I'm going to start with the fact that usually I would have this part, this 3i by itself on the right. I'm going to get it by itself. And so what I'm going to do is basically bring this back over to the left. So I'm going to subtract it from both sides. So now I'm going to have x minus 2 here. And notice how I'm going up. Okay. So that's 3i. Now, when you complete the square to get to this point, the step before that was to square root both sides. So that means before this, I had the square root of x minus 2, which also means that I square rooted some number to get 3i. What do you guys think I square rooted to get that? Or what would I have to take the square root to get? First of all, what would I have to take the square root to get 3? 9. But if it's an I, what else was the number? No, not 9i. What gives us an I to begin with? A negative. So it was a negative before, okay? So that's basically what I was taking the square root of to get to this point. Now, the square root's not part of the problem. It's not actually square root, but we're making the point that we had to square root negative 9 to get to the next step. All right, now, hold on, sorry, let me think for a second. We're going to want to, oh, my bad. That's what I'm forgetting. Sorry about that. What we did is we square rooted x minus 2 squared. Okay, it was x minus 2 squared. We square rooted both of these to get to the next step. Okay, all right. Okay, now what I'm going to do is expand this out. So now x minus 2 times x minus 2 equals negative 9. So now what I have to do is multiply that out. X minus 2, x minus 2 is x squared, negative 2x, and then plus 4. So I just multiplied all this out, add up those two like terms, negative 2 and negative 2, and then plus 4 here. And now I want it to equal 0 when I'm solving for a complex root or solving for a root. So that means I want to add the 9 back to the other side. Because it's negative, so I'm going to add it back. Now, if you notice, it's starting to look like the last problem where we got to this point at the end and we had that 4 plus 9 down here. So it's pretty much putting us in the same spot now. So now I pretty much start with this. This is what I would have started with to begin with. So I know you guys might be like, man, I don't remember complete the square. Okay, it's just some review of what you would do. So like if I was to complete the square, because I can't solve this with the x, in other words, but I could do quadratic formula, complete the square. And when you do that, you end up with something like this, okay? You end up with x squared, x minus 2 and x minus 2 when you do complete the square, okay? And then you square root both sides to get to this point, and then I have to add that number to get x by itself on this side, okay? So I'm gonna do one more example like that real quick. Okay, so let's say I had like negative 3 minus 4i. Okay, and let's work backwards again. All right, so here, x equals negative 3 minus 4i. I moved the 3 to here, and now it's x plus 3. Okay, actually, we'll start with the positive version. Okay, so we keep everything positive. Because you don't have to, because this is going to be plus or minus up here. So I'll just start with the positive version just to make things simple or simpler. Okay. Now, if I'm going back to the last step, I square rooted, so I had x plus 3, and then what was here? X plus 3 what? We're talking about like the last problem. Squared. Because remember, I had to square root to get to that point. So basically the square root just gets rid of the square. Which means if I squared it to get 4i, what did I have up here? Negative 16. All right, now I got to expand this back out again and multiply that. So over here, let's do the box. X plus 3, x plus 3, x squared, 3x, 3x, and 9. Sorry, I'm going a little fast because I don't want to take too much time on this. Okay, add those up. And then now I want it to be all on the same side. So what's my last step to go back up to the beginning? Add the 16 back to this side. And there is the equation that I originally would have started with. Okay. Okay, so that's how you work backwards on those types of problems. Okay. And then the next question is just like, what method would be the best to use out of those two? All right, you kind of can decide that. After that, it's review. It's what's the degree of the equation? Use these roots to find the set up the equation in standard form. Okay, and then here, finding the domain and range, you guys can use Desmos if you want to do that. Write the inverse like we did in the first week. Multiplying out complex numbers. If you want some review on that, go back to week 10. And let's see, actually, there's a good, I might go over to Mr. Nar's YouTube channel and complex numbers. So right here on 2 dots, the asterisk one, this one right here, this is a good place to look at for review of complex numbers. But again, we did that the last couple of weeks too. We talked about multiplying those out, okay? All right, I want to stop there. If you guys have any more questions online, please feel free to ask. I'll stick around for a little bit unless you guys are going to take off. I will see you guys mañana, tomorrow. And that's it.